Hello, everyone. This course, we will introduce some GRE VPN lab. Because we already know the GRE VPN principle, right? We can use GRE VPN to help us forward the message from private to private network. But between them, there is the internet. And here, we will use one lab to make our GRE VPN better to understand. And first, let's say the background of the lab. And here we use one city. For example, in China, we have one city, Beijing, and based Beijing, we have one company, and we have many branches across China. So, like the topology show, now if we want to use the GRE VPN to make the network connection between branches and headquarters, and then they can visit with each other. And how to give the configuration and what's the key command you have to do, something like this. And about this lab, the purpose is we hope you can master the application scenario of the GRE VPN technology and also can master some configuration commands and also how to check the status of the GRE VPN. And here is the topology. We have three routers. Route 1 to simulate headquarters, Route 2 to simulate the internet, and Route 3 to simulate our branch. And maybe in your internet, not only one device, you will have multiple devices. And another one is we also give the IP address. For example, about Route 1 and Route 3, both of them will have a loopback 0 address to simulate our service. And between two routers, we will have one physical link. And here is the IP address planning for the physical link. Okay. And the requirement is, the first three requirements is a basic network address planning, right? For the IP address of the physical link and also the loopback address. And the Route 2 simulate an internet device. In the Route 1 and the Route 3, Route 1 is a headquarter egress device. Route 3 is the branches egress device. And now if we want to let the 1.1.1 to ping 2.2.2 successfully, they also must have the routing information, right? How to get the routing information? We would use the OSPF protocol to do the communication between headquarters and branches. Okay. And if the headquarters adds a new service network segment, we can directly use the OSPF to do advertisement to my neighbor branches. Okay, so this is the routing protocol. Okay, now let's see the configuration plan. First, you have to finish the configuration of IP address and also the loopback address. Then, as we talk in the principle, before we deploy the GRE VPN, we must keep your public network connection is ready. So you have to give static routing configuration in Route 1 and Route 3. Okay. And then you have to deploy the VPN and enable your OSPF configuration. And here, why we use the GRE VPN? It's because GRE VPN can support multicast. Okay, and also the IPsec VPN cannot. But as we know, OSPF use multicast address to help find the neighbor and also send out some OSPF packets. So in this scenario, we must use a GRE VPN. Okay, and the last one, we have to configure OSPF over GRE. And then let's see the detailed configuration one by one. The first step is you must give the IP address configuration. Okay, Now let's configure it one by one. On route 1, you have two addresses. One is a loopback address and another is a physical link address connected with route 2. So first, create the loopback 0 and give the IP address 1.1.1.1.32. And another is your physical link gigabit 00 and give the IP address 12.0.0.1 and 24. Okay, so this is a basic for route 1. And for route 2, you have two physical link to connect with each other, gigabit 00 and IP address 12.0.0.2. And the mask is 24. And another is gigabit 01, IP address for 23.0.0.2, 24. And for route 3, we also have two IP address, one for the loopback 0. IP address is 2.2.2.2.32. And another one for the gigabit 00, IP address is 23.0.0.3, 24. 23. Okay, so now your IP address is ready. And then you have to give the static route to make the public IP address of R1 and R3 can ping each other. So on R1, you must give a static route. IP route 23.0.0.0 255.255.255.0 12.0.0.2. Okay, so this is the static route to it route 3. But about route 2, we don't need add other routing information because we already have two direct routes, right? But about R3, you must give a static route. 12.0.0.0 255, 255, 255.0. And the next hop address is 23.0.0.2. Okay, so now you can do the ping to test the public network connection is ready or not. Ping 12.0.0.1. It's okay, right? And then you can add the configuration for your GRE. It's very easy for GRE configuration. You have to create a tunnel 0, and give an IP address 172.116.1.1. The mask is 30. Pay attention. This IP address must be unique with the other IP address in route 1 because this also is the logical interface. Okay, and who will be the public source IP address? The source 12.1.0.0.1, the public IP address of route 1, connect with route 2. Okay, who is your destination IP address? 23.0.0.3. Okay, so if we receive some message and want to use the GRE, we will add the public source IP address and also the public destination IP address according to the configuration. This is a basic for route 1. And for route 3, also same. You have to create tunnel 0 and then give an IP address. This IP address must belong to the same segment of route 1 tunnel interface, 1.2, 30. And the source, the tunnel source is 23.0.0.3. The tunnel destination is 12.0.0.1. Okay, so this is a basic for your tunnel. And then you can enable the OSPF. On route 1, exist router OSPF 1 and the network 1.1.1.1 0.0.0.0 area 0. And another interface is your tunnel interface. 172.16.1.1 0.0.0 area 0. Okay, so this is a basic one for R1. And for R3, also router OSPF1, and you have to network your service segment for 2.2.2. Mask is 0.0.0 and area 0. And another is the tunnel interface 72.16.1.2 0.0.0 area 0. So in these scenarios, the tunnel also will send out some OSPF packets, but we already add the GRE configuration on the tunnel interface. So the OSPF message also will be encapsulated into the GRE VPN and sent to route 2. Because route 2 only is a public router, they don't know you already encapsulate the GRE message. So I will directly help you to forward the message to the destination 23.0.0.3 to R3. So the R3 will de-encapsulation and found this is OSPF packets. Okay, so now you will find the neighbor status will become full. And then you can check some results. First, you can show your tunnel interface tunnel 0. Okay, and here's some information for your status. Now it's up. Okay, and who is your source, who is your destination, you can find here in the tunnel attributes, destination, and who is your source. Now we check on route 3, right? And we use the protocol is GRE. But now, because we don't add the command of the GRE, right? We don't choose the protocol, the tunnel protocol GRE. That's because by default, we use the protocol is GRE. And now you can check how many packets already been sent use the GRE VPN. These are the packets summary, the output and input, right? Because we already use the OSPF encapsulate into the GRE and then to find our neighbor and send some routing information. So this is a basic one. And another one, you can check your OSPF status, includes your neighbor status and your routing information. On route 3, you can show IP OSPF neighbor, right? And you will find now we have one neighbor. So neighbor ID is 1.1.1, is route 1. And the interface is tunnel 0. And the status is full. And also you can check your IP routing table. Now we already get one routing from the OSPF. The destination is 1.1.1. And the next, the outer interface is tunnel 0. And then you can test the network connection. For example, on route 3, you want to ping 1.1.1.1 and use the source IP address. Oh, sorry, not in this command. Ping 1.1.1.1, use our 2.2.2 IP address. Now we can ping successfully. But if you directly ping, you also can ping successfully. So this is your network connection. You can find your network connection is ready. If now in the headquarters, we add a new service segment, you can directly use the OSPF to advertise the new segment to let the branches router, route 3, know this segment. And then you also can directly use the GRE to finish the network connection. For example, on route 1, if you add a new service, loop back 1 and give address is 11.11. 11.11 and 32, right? And also on your router OSPF, you network this segment. Mask 00 and area 0. Okay, so in this scenario on the route 3, if you want to check your IP routing table, you can directly find the routing information from OSPF, right? And if you want to pay 11.11.11.11 and the source 2.2.2, you also can ping successfully. It's very easy. Okay. Of course, in a real network, maybe you add the new service segment. You will use some physical switches or maybe physical server or physical terminals. But in this lab, we use loopback address to do simulator to simulate the service segment. And the key point of this lab is first, besides the OSPF, static route and BGP can function over the GRE VPN. So that's why this also is the advantage of the GRE VPN. And another one is the GRE VPN lacks encryption. That means if you use the GRE to send out a message and someone gets the message, they will know everything. Okay. So if you want to protect the traffic, maybe you can use the GRE and IPsec VPN together. Okay, and this function we also call is GRE over IPsec. If your OSPF want to use this VPN, then the full name we call is OSPF over GRE over IPsec. So if you want to make your message more security, you must use IPsec VPN together. And we also have one course to introduce the detail, what's the principle of the IPsec VPN and how to do the configuration of IPsec VPN. And about the GRE VPN, that's all. Thank you.